welcome back to my channel. So as the surface area and volume chapter is very important as the exam point of view, so I am going to explain first all the formula which are used in this chapter or which are going to be useful in this chapter. First of all, we'll take cube, very important. You know that cube, it has 6 faces in which all the faces are of squares. So shortly I am going to tell you. Here we will have lateral surface area LSA of cube is equal to, we have LSA means the side one. So we take it as 4 into side square. Why it is side square is side into side will give the area of one square. So if we take the lateral surface area, there are 4 faces. So we have LSA of cube is equal to 4 into side square. Similarly, TSA of cube is equal to, we will take total surface area where all the 6 faces we take. So it is 6 side square. And the last one we have volume of cube. Volume is the space occupied in the cube. So we have it as side into side, or it is S cube. Some of you use it as L, some of them also use it as A. Anything you can take it, but its meaning is same. Where in square we have one value which are all equal. So we can use any alphabet that is can be used. Either if you use A, it becomes A cube, or A into A. If you use L, L cube, or L into L. If you use S, S into S. If it is TSA, it is 6 into S square. LSA, it is 4 into S. Next we have cuboid. Students, the difference between cube and cuboid is, cuboid also has 6 faces, cube also has 6 faces, but in cube there are all the 6 faces are squares, but here the faces are rectangles. Only top and bottom will be same, and remaining all the 4 faces will be same. They are rectangles. So we will take now LSA of cuboid. So what it will be now? LSA. So you can take this example only. So here are the 4 faces. This is lateral surface area. So if we consider this as length and this is breadth, so we have to take the area of 4 rectangles now. So 4 into area of rectangles. If you take, it is 4 into, but here rectangles means it is a cuboid. So this will call it as height. So this rectangle area becomes L into H. Here it is breadth into H. Again L into H, B into H. So instead of 4, we can write L into H plus B into H plus L into H plus B into H. Similarly, 2LH, if we add them LH plus LH, and 2BH, so 2 common LH plus BH. Here H also can be taken common. 2H is equal to L plus B. This is the lateral surface area of cuboid. Now TSA of cuboid is again LSA plus area of top and bottom, area of top plus bottom if we take, it is already, we will write this now, 2LH plus 2BH. Now area of top is now length into breadth it becomes. So it is length into breadth, 2LB. Now finally we arrive to the formula that 2 into bracket LB plus BH plus LH. This is the TSA of cuboid. And the volume of cuboid is very easy. So always for the volume we take area of the base into height. So what is the area of the base now? It is rectangle. Volume of cuboid area of the base is rectangle, that is L into B, area of rectangle, into height. So volume of cuboid is LBH.
1.
Next we have cylinder. Already these things you have studied in 9th standard, students. This is just like a revision. So for the cylinder, we can also call it as LSA or curved surface area. In cubes we cannot call it as curved because it is not a curve in shape. But here cylinder you can call both curve and L, lateral or curved surface area. There are two circles, top and bottom, and just we'll take this as radius and this as height. The cylinder, you know this. So for this lateral surface area, just if we take a rectangle shape paper and fold it, it will become a cylinder. So for that area of rectangle into height if we take, we will get the cylinder. So that is 2 pi RH. You can take it as CSA or LSA of cylinder is equal to 2 pi RH. Next we have TSA, that is total area, surface area of cylinder. Already LSA we have taken. LSA only will write plus. Both the circles are same top and bottom. So we will write area of two circles. So for this you should know the area of circle. Now LSA is 2 pi RH plus 2. Area of circle formula is pi r square. So if we take it pi r square, you can use like this only formula, or to make it simplify, we can take 2 pi r. There are two r's, one r can be taken common. 2 pi r into bracket h plus r. This is the formula used for TSA of cylinder. Now next, volume of cylinder. Volume of cylinder is again the area of the base. Base here is circle. So the area of circle is pi r square and the height is h. So volume of cylinder is pi r square h.
Start.
Yes. Next we have cone. So cone, as it has the slant shape, here we have slant height, we take it as L. This is the radius. Only one circle we have and it has only one vertex. So we'll take LSA or CSA of cone as. So if we cut them and form as a triangles, we get the formula as pi r L. L here is slant height. Students, for example, if L is not given, instead of that height is given. Always height will be perpendicular to the base. Remember, there is a lot of difference between height and slant height. So if H is given and L is not given, then how to find the L? So that time we are going to use the formula L square. Here we form, it's a right angled triangle. Applying the Pythagoras theorem, we have L square is equal to R square plus H square. So L is equal to root of R square plus H square. Using this formula, we have to find L, then continue the question. Similarly, if L is given, H is given and you are asked to find R, also you have to transfer the values and you have to find the what you want. Next we have TSA of cone. So it is LSA plus area of one circle. That is area of circle. So LSA is pi r L plus pi r square. So if you take pi r common, L plus r is the TSA of cone. And volume of cone we take it as, if we take the height and radius of cylinder and cone same, we have got volume of cone as 1/3 the volume of cylinder. 1/3 the volume of cylinder. So what is the formula to find the volume of cylinder? 1/3 pi r square h is the volume of cone. So next we have another new one which you might not have heard, that is the frustum of cone. When you cut the cone parallelly, so you get frustum of cone. Example, your buckets is the best example for a frustum of cone, where the only difference is the circles are varied by the radius. The radius are different in both the top and bottom circles. So the formula of cone, if we take now, frustum of cone, LSA if we take, so the cone, LSA of cone is pi r L. So here we take L. As the radii are different, we are going to take now R1 plus R2. So this is the LSA of cone, frustum of cone. Now TSA of frustum of cone is, for the TSA of cone it is, what is the TSA of cone? Pi r into bracket L plus R. Now we take pi L into bracket. So TSA of frustum of cone is pi L plus area of the circle with R1, that is pi R1 square, that is the another circle with R2, area of pi R2 square. This is the TSA of frustum of cone. Next we have volume of frustum of cone. Volume of frustum is equal to 1/3 pi h. So that is R1 square plus R2 square plus R1 into R2. This is the volume of, in the cone we had 1/3 pi r square h. But as there is difference in R1 and R2, we are going to take now R1 square plus R2 square plus R1 into R2. So these are the formula related to cone. So last left is sphere. So the sphere we have only, its best example is your ball or globe. The earth, our earth itself is the best example. So we have R. When we have calculated here only one curved surface area, there is no separate CSA, TSA, both are same, only one surface area we get. So that we take it as TSA of sphere. That is 4 pi r square. You may be having the doubts, how did we get this 4 pi r square? We cannot measure properly on the ball. But what we do here is, if we take the example of shot put, if we cut it into two parts, then we will get two hemispheres. So those hemispheres are taken as an example or to study, and we got there now. So in the hemisphere we have CSA of hemisphere becomes, C of hemisphere is 2 pi r square and TSA of hemisphere is 3 pi r square. So when we join two hemispheres, we will get 2 pi r square plus 2 pi r square, it is 4 pi r square. So if we take only hemisphere, if it is solid one, then area of the top circle plus the curved one will become 3 pi r square. And volume of hemisphere is 2/3 pi r cube, and volume of sphere is 4/3 pi r cube. This is found out using the volumes of cones. As you can see here, the sphere is made up of a number of cones. If you hold the cones completely all the through, then we get their surface areas as a sphere. Using the volumes of cones, if we calculate, we get the volume of sphere as 4/3 pi r cube and hemisphere as 2/3 pi r cube. Actually, we mostly use hemispheres only. Your bowl is the best example. More than sphere, we use hemisphere.